Okay, right. Okay, so what we are going to do today is kita tengok beberapa soalan regarding on the topic today, which is flywheel. Alright, so before we start with some exercise, any question so far that you want to ask? Tak ada, semua faham topik ni? So before we start, let me recap back. I summarize what happened for this topic. All right. So basically, for this topic, we have two types of problem that we have. First is we call as type number one. What is type number one? Right, so basically for type number one, we have a variable input will produce a constant output. Okay, and for type number two, we have a constant output will produce a variable output. Alright, so the procedure is more or less lebih kurang je, cuma bezanya adalah bila kita nak superimpose ataupun kita nak tentukan the value or the value of energy. All right, so for type number one, we need to for areas with this upper than a T mean, that we need to consider as a positive, but if we have a below then T mean, that we need to consider as a negative. But for type number two, all right, type number two, we need to have a negative is upward and positive is downward. Alright, so kita ada tiga terms and condition that we need to know. First is, biasanya soalan dia akan tanya lebih kurang macam ni lah. So kalau soalan nak tanya what is coefficient of fluctuation of speed, then this is our equation, right, which is alpha equals to omega maximum minus omega minimum divided by omega mean. And what is mean? Mean is omega max plus omega mean divided by 2. Right. We also have a coefficient of fluctuation of energy, which is beta here, and then we have equation of mass moment of inertia of flywheel system, which is beta E divided by alpha omega mean squared, right? And then this is work done per cycle, and it's number of working strokes or second. Okay, so this here we are. This is our strategy. Saya tengah buka slide ke? Tengah buka, tak nampak tak nampak kejap. Sorry. Okay, so this is our slide, nampak So this is our solution strategy. How many steps we have? We have 6 steps. All right, first is about we need to identify the type, and then we need to identify one cycle, and you need to check also the axis of x. You must convert it to in theta, which is kalau dia bagi dalam bentuk time, then you need to convert it to theta, which is theta equals to omega t. And then number 4, you need to start with conservation of energy, check for one unknown, and then superimpose. Yang ni a very critical part lah biasanya, superimpose of two graphs, and then from here we need to determine all areas and also energy analysis. And then number 6 is 3 equation. Okay, so yang ni saya dah tunjuk dalam video, then you can check it out balik, and then we cuba kita tengok this question. Alright, question number 3. Okay, a motor electric driving a punching machine produce a constant torque of 50 Newton meter on the flywheel, okay, which rotates at a speed of 300 rpm. The variation of torque required by the operation of crank is shown. Based on the turning moment diagram, determine total number of punching operation can be produced in 1 hour, and then we need to find maximum fluctuation of energy in one cycle operation, and last one, maximum and minimum speed in one cycle if mass moment of inertia is given as 10 kilogram meter squared. Okay, first is you need to determine what types of flywheel here, type number 1 or type number 2. One or two? One. Are you sure one? A motor electric driving a punching machine produce a constant speed, a constant torque. Produces constant torque. Okay, so kat sini dia beritahu punching machine. So bila punching machine biasanya type yang melibatkan punching machine adalah number 2 lah, type number 2, which is will produce 50 Newton meter on flywheel, alright, which rotate at a speed of 300 rpm. So if type number 2, what we have is kita akan ada we are given 50 Newton meter torque, a constant torque on a flywheel. Alright, so apa yang kita boleh buat adalah first adalah we need to find a total number of punching operation can be produced in 1 hour. Okay, so first we have type number 2, and the second is terus kita tengok identify dia punya x-axis, which is in terms of t, isn't it? But so we need to ensure that our our x-axis must be in terms of theta. Alright, so if we draw our conservation of energy, alright, so basically we have constant torque 50 Newton meters in it. So one complete cycle start from what to kat mana? One complete cycle. One complete cycle means that we start with from 0 until here lah. So ini we consider as one complete cycle. One cycle. So meaning to say that from 0 from here is unknown, so we don't know what is our time, so we just consider as t here over here. So this is theta, and then one complete cycle from 0 until here should be this one should be t plus 1 omega. Okay, since theta equals to t omega, alright, theta equals to t omega, so we have t plus 1 omega for one complete cycle. So this is 50 Newton meter. Okay, so this is our constant torque mean. Alright, so we'll produce energy here, which is this is 50 and this is 150 somewhere here, 150. So this is kurang lah. Okay, so kita ada macam ni lah, lebih kurang. Okay, so this is our theta, and this is omega t. So this is omega t plus 1. Okay, so this is our conservation of energy. Alright. Okay. So from here we can actually find what is our unknown. Our unknown is t, isn't it? So we need to find t first. So based on conservation of energy, what we have is we have 50, okay, times with t plus 1 omega equals to right hand side what we have, since this is same area, isn't it? So same area, so kat sini sama. So we can actually just dapatkan satu area sahaja. So what we have first is we have Kalau kita tengok balik, kita punya area dekat sini, okey, kita boleh pecahkan kepada 1, 2 kat sini and 3. Betul? 3. So what is our area kat situ adalah kita ada 50 times with berapa dia punya jarak dekat sini? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from here to here we can consider as 0.4 t, isn't it? 0.4 omega, 0.4 omega. Okay, dia punya jarak kat situ. Since dia dah bagi kat sini from here to here ia adalah 1 saat. So kat sini must be 0.4 omega. Okay, plus with number 2 which is 1/2 times with 50 times with 0.1 omega. And last one, number 3 is we have plus 1/2 times with 100, isn't it? 150 minus 50, so we have 100 times with 0.4 omega. Okay, so there is our equation. So from here we can actually find what is our t. So simplify this one, then we get t must be 50 t plus 1 omega should be berapa ni? 50 darab 0.4 85 kan? Tak, 85 omega. So cancel out omega, then we get t must be 0.7. So there is our t. Betul tak? T sama 0.7. Okay, so once we get t, then to complete one cycle, so requires t time for one cycle. Alright, time for one cycle must be 0.7 plus 1, which is 1.7 second. So from here actually dia memerlukan 1.7 saat untuk menghasilkan satu produk. So how many total number of punching operation can be produced in 1 hour? So just interpolation je lah. So untuk dapatkan how many number of punching operation. So 1 punching, alright, sama dengan 1.7 saat. So how many punching machine operate in 1 hour? 1 hour equals to 3600 second. So from here, so then we have n equals to 3600 divided by 1.7 seconds. So almost lebih kurang dalam 3600 bagi 1.7, 2117.6. So somewhere dalam 2118 lah kan, 2118 lebih kurang lah. Alright, betul tak? So that is our n, number 1. Any question? Ada soalan nak tanya? Okay, number 2, maximum fluctuation of energy in one cycle operation. Right, maximum fluctuation of energy in one cycle operation. So dekat sini baru kita akan pergi kepada step number 5, superimpose the graph. Right. 50 0.4 dah boleh dapat mana? Dekat graph lah. dekat graf ni. Kita tahu kat sini 1 second. Sini. Jadi kat sini 0.1 omega, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Jadi dari sini ke sini adalah 1 second. Convert dalam omega, kita akan dapat 1 omega lah. Alright, 1 omega. Alright. So next, nak dapatkan maximum fluctuation of energy, kena superimpose untuk dapatkan dia punya beta E lah. So maximum fluctuation of energy ni kita nak dapatkan beta E, BE. So BE. So macam mana? So kita buat graf, superimposekan graf kita. Okay. So this is our 50 dekat sini. And then sekejap saya padam balik. Okay. Kat sini theta. And then kat sini 50. Ni kat sini 150 lah, lebih kurang. Okay, sekarang ni adalah kita nak superimposekan graf. So this is our T min. Alright, T min. Dia punya apa kita panggil benchmark kita lah. Alright, so start with 0.7. So dekat sini of course 0.7 isn't it? 0.7 omega until 1.7 omega. Okay, so 1.7 dekat sini 1, maksudnya dekat sini must be 1.2. So 1.2 omega. And then kat sini ada 0. Kat sini 0.7, 0.8. 0.8 omega. And then kita ada juga 1 omega dekat sini, 1 omega, 1.4 omega, and then last kali kita ada 1.6 omega. Okay, so sekarang ni 1.2 adalah point dekat sini, and then 0.8 point dekat sini. Ada lagi 1 omega dekat atas. Okay, dekat atas. And then lepas tu kita ada 1.4 omega dekat atas. And then 1.6 omega dekat sini. And last one 1.7 dekat bawah. So just drag je lah. Kita punya graf. Sini 1, tadi 1.4. Ya Allah. 1.4 dekat atas ni. Sini 1.6 dekat sini, and then 1.7 dekat sini. Sama, lebih kurang 1. And then kita first adalah tentukan kita punya point of intersection. Alright, point of intersection first we need to start with here lah, dekat sini. So this is point A, this is point B, okay, this is point C, this is point D. Dia still tak cukup satu complete cycle kan. Yang untuk cukupkan one complete cycle dia mesti sampai 1.7. So dekat sini, so this is point E lah. Okay, point E. So dekat mana dia punya area yang kita nak consider? Dekat sini, yang di mana dia overlap. Alright, first dekat sini, okay, and then dekat sini atas, dan dekat sini, and last one dekat sini. Okay, clear? So that is our area of point. Okay, faham dah macam mana nak tentukan superimpose area yang diperlukan. Okay, kenapa yang bawah tu tak ambil? Yang mana tak ambil? Dekat bawah ni kita ambil sebab kita nak superimposekan dia. Kita nak ambil yang area yang between nilai yang terlibat, yang ada energi. So energi untuk T min yang ada adalah dekat sini lah. Untuk sekarang ni graf kita nak superimpose. Bila superimpose, kita ambil area yang dia overlap. Contoh yang overlap dekat sini, yang between 51 dekat sini. Dekat sini tak boleh ambil sebab dia ada macam energi between yang dalam ni, okey, ke atas ni, antara 50 dengan 150. So kita ambil yang di mana area yang betul-betul berada dalam, macam mana nak cakap, saya pun susah nak cakap ni, tapi dia punya nilai area tu kena ambil yang overlap lah. Contoh kan, saya ambil yang lain, contoh lain lah. Okey, kalau contoh lain, kalau saya ambil, okey, contoh kalau saya ambil macam ni, naik atas. Okey, yang point itu apa clear? Okey, point E tak berapa. Kita sekarang ni nak ambil yang one complete cycle. This one is one complete cycle. Alright, one complete cycle. So kalau kita ambil sampai point D, dia still tak cukup satu complete cycle. Sebab point D tu hanya sampai 1.6 omega. Dia bukan 1.7. Jadi 1.7 mesti dekat point E. So maksudnya untuk point E kena consider jugalah. So this is our area yang kena consider. Okay, contoh kalau kita ada graph macam ni. Okay, let's say this is one complete cycle. So sekarang ni dia punya T min di kat sini. Saya ambil. So kat mana dia punya yang area yang overlap? First adalah dekat sini. Contoh this is A, B, C, D and E. So yang overlap hanya sini satu, sini satu, sini satu, dekat sini satu. Tu je. Faham? Ikut line. So ikut line dia. Contoh lagi, kalau kita ada macam mana nak buat? Contoh this is our T min. So yang overlap hanya dekat sini. 1, 2, 3. Macam itulah lebih kurang. Okey, faham Okay, so this is our superimposed graph. Okay, sekarang ni kita nak tentukan case. Since this is tab number 2, maksudnya dekat bawah dia must be positif lah. So this is positive. So this is positive A, negative B, negative C and positive D. Positive D. Okay. So sekarang ni kita nak tentukan area. Area of A. So what is our area of A? For A. Kat situ adalah triangular kan. So kita ada 1/2 darab dengan 0.7, which is jarak dari sini tambah 0.8 darab dengan 50. 0.7 omega tambah 0.8 omega darab dengan 50. Then area of A should be 37.5 omega. Area of B pula. So what is our area of B? Since B dan C tu lebih kurang sama sebenarnya. Jadi kita boleh jadikan dia sebagai B sama dengan 1/2 darab dengan 100 0.4 omega which is 20 omega. C pun sama 20 omega. And D sama dengan 1/2 darab dengan 0.1 omega times with 50. Then D equals to 2.5 omega. So that is our A. This is our B, C and D. Okay. So sekarang ni we need to find flywheel energy at each point. So point A, B, C, D and E. Alright, flywheel at each point. So point A, what we have? Let's say we start with U. Okay. So energi dia akan makin bertambah bila mana dia pergi ke point B. So B equals to U plus A, which is A is 37.5. Then we have U plus 37.5 omega. And point C. Alright, so bila dah melepasi point B, dia akan makin berkurang. Alright, makin berkurang sebab kita tolak dengan B. So kita ada U plus A minus B, which is U plus 37.5 omega minus 20 omega equals to sama dengan U plus 17.5 omega. And how about D? Still kita tolak U plus A tolak B minus C. So U plus 17.5 omega minus 20 omega again. So we have U minus 2.5 omega and point E. So we have U plus A minus B minus C plus D. Then we have U minus 2.5 omega plus 2.5 omega. Then we have E sama akan back kepada U balik lah. So bila kita dapat E sama U balik, maksudnya kita punya one complete cycle betul lah. So dia akan repeat balik kepada energi yang asal sama macam U. So dia akan naik, energi naik, makin naik, and then dia akan turun balik sampai dekat point yang asal U. So bila kita dapat U balik, maksudnya kita punya area yang kita kira ni betul lah. So bila kita check kita dapat U balik. So betul. Okay, so sekarang ni from here we can actually identify which one is maximum energy and which one is minimum energy. So from here our maximum energy should be dekat B, isn't it? So this is our maximum energy. So where is our minimum? Minimum must be dekat mana? Dekat D. So this is our minimum energy. So untuk dapatkan maximum fluctuation of energy in one cycle operation, then number 2 is beta E lah. So E maximum minus E minimum. So E maximum kita berapa? U plus 37.5. U plus 37.5 omega minus U minus ini minus 2.5 omega. Then U boleh cancel out, then we have 40 omega, which is omega berapa? So 40 times 300 times 2 pi over 60. Then our BE is 1256.6 Newton meter. So that is our answer. Okay, so far okay, faham setakat tu? Any question nak tanya? Ada soalan tak? Faham Okay. So number 3, we have maximum and minimum speed in one cycle if I is given 10 kilogram meter squared. So what is our equation of mass moment of inertia? I equals to BE over alpha omega square, isn't it? So which is equals to 10. Alright, so kita tahu we have 10 equals to BE is, kita ambil dalam bentuk 40 omega lah, senang. So BE is 40 omega divided by alpha. We don't know alpha, isn't it? But it's okay. We just put it as alpha here. Alpha times omega squared. Since omega is same, then kita boleh cancel out lah. So we have kita akan ada maximum speed to alpha. Maximum speed mana? Maximum speed alpha boleh sebenarnya. Alpha adalah this is our alpha, coefficient of fluctuation of energy speed. Alright. Biasanya bila kita dapat coefficient dia dalam bentuk percentage lah. Tapi it's okay. Dalam soalan ni kita bukan nak dapatkan alpha, kita nak dapatkan dia punya maximum and minimum speed, which is omega lah, omega max and omega min. Omega maximum dan omega minimum. Omega yang dia bagi adalah omega min. Alright, omega min. Tak sama tu, omega min, omega maximum dan omega minimum. Alright, there are 3 different things. So dekat sini kita boleh dapatkan dia punya alpha omega should be 4. Okay, clear. So apa kita punya equation of fluctuation of energy? Kita tahu yang dua tu dia nak beta E ke dia nak beta E. Maksudnya maximum fluctuation of energy itu adalah beta E, bukan E saja, beta E. Okay, kalau dia tanya maximum fluctuation of energy in one cycle operation, maksud dia nak dapatkan dia punya nilai energi yang adalah untuk dalam satu complete operation, one cycle operation. So kat situ maksudnya maximum beta E dia nak. Okay, beta tu macam constant. Beta tu adalah bukan kat sini saya ada ni coefficient, constant lah, coefficient of fluctuation of energy, coefficient. Okay, coefficient maksudnya maximum energy minus minimum energy bahagi work done per cycle. So kalau kita olah balik dalam equation yang ni macam ni daripada sini, so kita boleh dapatkan dia punya coefficient macam ni lah. Alright. Okay, so next adalah mana tadi? So this one. So kita ada alpha omega equals to 4. So kita tahu equation of alpha sama dengan berapa? Alpha sama dengan mana alpha? Equation of alpha. Where is it? This one, isn't it? So kat sini kita tahu this is equals to 4. Bukan equals to 4, maksudnya bila kita kita olahkan balik, so kita dapat kat sini equation ni mana tadi? Ada silap. So kita ada alpha omega sama dengan omega max minus omega min, sini alpha omega. So kita compare dengan apa yang kita dapat yang ni. So kita ada alpha omega sama dengan omega max based on equation minus omega min. So dan kita tahu, so kita boleh dapatkan equation omega max minus omega min equals to 4. Then this is our equation number 1. Okay, and then second equation comes from equation of omega min. Alright, so kita tahu omega maximum, so omega min sama dengan omega maximum plus omega minimum bahagi dengan 2, isn't it? So kita tahu omega min adalah berapa? 300, isn't it? Terus 300 darab 2 dalam 600 lah. So omega max plus omega min equals to 2 times 300, which is 600. So question number 2. So from here kita ada dua equation with two unknown dan kita boleh dapatkanlah nilai omega maximum dengan omega minimum. So from here omega maximum should be 302 rpm and omega minimum must be 298 rpm. So that is our equation. So sorry, this is our answer. Okay, clear? Ada soalan nak tanya? Tak ada? Okay, so done. First exercise. Okay, second exercise. Cuba tengok betul-betul. This one. Alright, so type number 1. Saya pun confused juga type 2 ke 2. Tapi kalau kita tengok dekat sini, basically kita boleh consider as figure question 3 shows a variation of torque against time for an engine which is running at the speed between 495 and 505. The engine operates a machine which requires a constant torque. Maksudnya dekat sini type number 2 ni. This is our product sebenarnya. This is our product. Variation of torque against for an engine which is running. So determine mean speed of the engine. This is again type number 2. 2 ah? Betul lah 2? Ke 1? 2, saya rasa 2. Saya rasa 2. 2. Sebab biasanya kalau yang type number 2 dia akan bagi dalam bentuk theta T. Untuk type number 1 dia akan bagi dalam bentuk theta. Terus. Okay. Boleh bezalah. Figure question 3 shows a variation of torque against time for an engine which is running at the speed between 495 and 505. So the engine operates a machine which requires a constant torque. Memerlukan constant torque. Maksudnya betul lah type number 2. So input dia must be constant torque, will produce a variation of torque yang ada dekat question figure. Okay, so first kita nak dapatkan mean speed of the engine. So kita boleh direct kepada conservation of energy lah untuk dapatkan dia punya, ataupun kita boleh dapatkan mean speed dulu. So what is our mean speed of energy? Which is omega mean. Right, omega mean equals to, guna equation terus lah, plus omega mean divided by 2. So which is 505 plus 495 bahagi 2. So we have 500 rpm lah. So this is our answer. Okay, B, coefficient of speed fluctuation, which is alpha. So sama juga kita boleh guna equation which is alpha sama dengan omega max minus omega min bahagi omega min, isn't it? So we have 505 minus 495 bahagi 500. So we have alpha equals to 0.02, isn't it? So this is our alpha. Okay. And C, mean torque of the engine, hence the engine power. Mean torque maksudnya kita kena buat conservation of energy lah. So what is our conservation of energy? Kita ada torque mean, which is one complete cycle. Kat mana one complete cycle? Dia start daripada -10, maksud dia repeating sampai mana? Sini kan? Sini. So this is our one complete cycle. So this is our one complete cycle. Jadi dia punya one complete cycle masa dia sampai berapa? 0.245, 0.8 sini. So 0.8 omega. So this is theta. Okay, so that is our T mean. We don't know what is our T mean. Alright, equals to we start with -10 and this is -20, and then kita ada 55 and 60. So dekat sini kita ada 0.2, start with -10 and then naik sampai 55, back kepada -20. Okay, and then sini 0.1 naik balik sini, and then akan pergi ke 60 lah, and then stop dekat sini. Okay, so kat sini 0.2 omega, 0.2 omega, 0.1 omega and 0.3 omega. So that is our area. Okay, so sekarang ni kita nak dapatkan T mean. So T mean times with 0.8 omega equals to kiralah semua area yang kita ada. Okay, so what is our area? We have area sama dengan kita ada -10 kan. A tolak B, C tolak D. Tak, masa sekarang kita bukan superimpose lagi. Kita nak dapatkan dia punya T mean dulu. So T mean left hand side must equals to right hand side. So kita ada -10 times with 0.2 omega, isn't it? And then plus with 55 times 0.2 omega minus minus 20 . So minus 20 times with mana tadi? 0.1 isn't it? 0.1 omega, and then plus with 1/2 0.3 omega times with 60. Okay, so what is our T mean? Cuba kira, cuba dapatkan T mean. What is our T mean? Cepat dapatkan T mean. Betul. So T mean kita sama dengan 20. So this is our answer lah. 20 Newton meter. Okay. And then D. Okay, D kita nak dapatkan apa? Radius of the flywheel to be fit to the system if the material density is 8500 and the ratio of radius of thickness is 4. Macam mana nak buat tu? Ada apa tu? Material density dan juga ratio of thickness. So any idea? Okay, sekarang kita nak kena dapatkan, we should have the apa, the value of I. Betul, kita nak dapatkan dia punya radius dan kita kena cari dia punya nilai I first. So how to find I? Mass moment of inertia. So dapatkan mass moment of inertia, cari K, dah dapatkan mass moment of inertia dan dapatkan dia punya R terus lah. R, then you must know our our equation of flywheel for mass moment of inertia apa dia? mr square ataupun 1/2 mr square. Flywheel dia macam disk juga kan, so sebenarnya kita boleh consider as m 1/2 mr square ke 1 mr square sahaja. Flywheel kita boleh consider as a disk, saya tak silap, so kita boleh ambil 1/2 mr square, 1/2 mr square. Okay, betul, sebab flywheel dia tak consider sekali motor, so kita just ambil terus nilai flywheel as a disk, which is 1/2 mr square. So next step adalah kita kena superimpose the graph. Alright, superimpose the graph, then what happened to our graph? Okay, so one complete cycle, this is theta, and then kita ada -10, -20, and then we have 55, and we have 60 dekat sini. Dan tapi dalam video so macam pakai mr square, 1 mr square. Video mana? Saya tengok ini. Ada tak kat sini? Oh, ini example ni atas lagi. Ada lagi saya sudah tak ingat dalam satu ni. Yang ni ya. Video cat learning. Saya rasa ni. Yang ni kan? Dimension after mana lagi? Kalau soalan yang macam ni, sebab soalan ni dia melibatkan the figure shows relationship between torque and time. Dekat sini dia sekali flywheel tu dia sekali dengan motor. So bila sekali motor, maksudnya kita assume consider as radius of gyration. Kita dapatkan radius of gyration sebab dia bukan I over yang kita dapat ni not flywheel itself, dia sekali dengan I motor, sebab the machine is driven by electric motor at constant torque. Alright, at constant torque maksudnya dia punya shape is not constant as this. Maksudnya on this case we need to find I overall first, and then from here kita kena tolak dengan I motor untuk dapatkan dia punya I flywheel. Okay, maksud I overall tu based on mk square. Alright, mk square. Okay, tapi tak apa sebab because this one is flywheel itself, dia tak melibatkan motor. Ya ke? Sekejap saya tengok. Tak ada motor. So just terus engine operates a machine which requires constant torque, terus digunakan flywheel saja. So kita kena consider as 1/2 mr square lah. Okay, so kita superimposekan dia punya graph ni, and then what happened to our graph? So start with kat sini 0.2, and then 0.2 kat sini series 0.4 kan. So kat sini 0.1 and 0.3. So this is our one complete cycle. So -10, so naik dekat atas, okay, back kat sini, and then dia turun bawah sini, sorry, sini, naik sini, and then dekat sini lah. And then our T mean adalah 20. 20 dekat mana? Dekat sini, sama dekat sini. So this is our T mean. So our graph yang overlap should be kat sini lah. 1, 1, 2, and then we have 3 kat sini, and last one we have over here. Okay, so this is A, B, C, D and E. So dekat sini adalah positive A, this is negative B, positive C, negative D. Okay, so sekarang ni kita nak kena dapatkan dia punya area of setiap area yang ada kat sini. So before we move to find the area, then kita kena pastikan yang H parameters yang ada ni boleh gunalah. Maksudnya dekat sini 0.2, kat sini okay. This one should be 0.2, sini omega, kat sini pun 0.2 omega, dekat sini okay, kat sini kita tak tahu jarak between sini ke sini, we don't know, isn't it? So we need to find it first, jarak dekat situ. So from here kita kena buat interpolation method lah. So let's say this is C prime, okay, dekat atas ni. So let's say this is C prime. So C prime to D over, kita ambil this one is 20, isn't it? So 20, C prime to D is 20 equals to 0.3. So kita ambil this one lah, 0.3 omega. 0.3 omega over 60. Okay, clear this one. Kita ambil yang interpolation and this one. Okay, so this is 60, ambil this one, this is 20, okay, and then kita ambil yang first ada segitiga this one, and second ada segitiga this one. Okay, clear tak? Boleh? Okay, so kita ambil dua segitiga, buat interpolation, and then kita akan dapat C prime D should be 0.1 omega, isn't it? So 0.1 lah, between C prime to D 0.1. Alright, so ada lagi tak yang unknown value? Tak ada lah. So kita dapatkan dia punya area lah masing-masing. So area A. So what is our area of A? Area of A is 30 times with 0.2 omega, which is 6 omega. Area B. What is our area B? Area B is 0.2, isn't it? Mana? Betul, 0.2 omega, ataupun kita ambil 55 tolak dengan 20, 35 lah. So 35 times 0.2 omega. Then we have 7, isn't it? Betul, 7 omega. And then what happened? So area B, area C. Area C dia ada dua dekat situ. First adalah yang rectangular, satu lagi triangle kan. So kita ada 0.1, and dekat sini berapa ni? 0.1 kan, 0.1 omega. So 0.1 omega times with 20 plus 20, 40 omega, sorry 40 plus with yang segitiga yang kecil ni. So plus 1/2, 20 times with 0.1 omega. Okay, betul. Then the answer is 5 omega. And last one, area D. So what we have? We have 1/2, 60 minus 20, so 40 times with 0.3. 0.3 Sekejap, 0.3 or 0.2? 0.2, isn't it? So 0.2. Then 0.2 omega. Then the answer is 4 omega. Okay, 4 omega. So kita dah dapat this one, dan kita boleh dapatkan flywheel energy at each point. So A, B, C, D and E. So flywheel energy at point A. So this is U, isn't it? You start with U, and then point B, we have U plus A, which is U plus A. Our A is 6 omega. And then point C, we have U plus A minus B, isn't it? Sorry, U plus A, betul lah. U plus A minus B, which is B is 7. So U plus 6 omega minus 7 omega equivalent to U minus omega. And then point D, we have U plus A minus B plus C, isn't it? Minus B plus C. So we have U minus omega plus 5 omega equals to U plus 4 omega. And last one, we have point E, U plus A minus B plus C minus D. Minus D, which is D is 4. Then we have U plus 4 omega minus 4 omega. So betul lah. So kita dapat point E sama dengan U. So kita punya area semua betul. So start with U and back to U. Start point A and back to point E as U. Okay. So that is our energy. So where is our maximum energy? Which point? Point dekat mana? Resulting in maximum energy. Point B, isn't it? So point B is maximum. So this is E max. And where is our minimum? Minimum is point E minimum. E minimum. E minimum. Alright. So from here we can find BE. So dapatkan dia punya BE, which is 7 omega, isn't it? So 7 omega. 7 omega. So once kita dah dapat 7 omega, dekat situ kita boleh guna equation, which is I equals to BE over alpha omega square. BE alpha omega square, which is 7 omega over, what is our alpha? Alpha dah dapat tadi kan? Which is 0. Tadi 0.02. So 0.02 omega square. So I flywheel kita sama 7 bahagi dengan 0.02 darab dengan omega. Omega berapa What is our omega? Omega mean 500 rpm. So we need to convert to meter per second. So radian per second. So 500 times with 2 pi over 60. So berapa? Dapatkan I. Find I. What is our I? .6845, betul? 6.68. Okey lah. So 6.6845 kilogram meter square. So this is our mass moment of inertia for flywheel. Alright, flywheel dia tak termasuk motor sebab dekat soalan ni tak ada motor. We have no motor. Okay, so flywheel, then what we have is that from flywheel we know that flywheel kita can consider as 1/2 mr squared. Alright, kat sini lah. So I equals to 1/2 mr squared. Then kita boleh convert m dalam bentuk rho v, isn't it? V adalah density, sorry, V adalah volume, rho adalah density. Density is given it as 8500. Okay, 8500. So what is our volume? Volume, so kita boleh convert as m equals to rho, volume sama A times with T. What is our A? M rho A adalah m r squared times T, isn't it? Sorry, m r squared pula. Pi r squared. Pi r squared. Pi r squared T. Alright, so dia dah bagi bagi tahu guys, so ratio of radius to thickness is 4. Radius to thickness maksudnya apa? What does it mean here? Radius to thickness is 4. So R/T equals to 4. Then we have R equals to 4T ataupun T sama R/4 lah. So masuk dalam equation ni kita akan dapat M equals to rho pi R squared times with R/4. Okay, clear. Then M kita akan dapat rho pi R kuasa 3/4 lah. So masuk balik dalam equation ni dan kita akan dapat I equals to 1/2 rho pi R to the power 5/4, isn't it? Then I equals to 1/8 rho pi R to the power 5. Betul. So since kita dah dapat I equals to 6.684, then from here we can get what is our R. So cuba kira what is our R. Dapatkan R. What is our R? Dapat? Kira nilai R berapa? (0.2886) 0.2886, betul? Semua dapat sama? 0.2886. So that is our answer lah. Okay. Okay, clear? Itu je exercise. Dah lah, cukup lah tu. Penat saya explain. Alright, so kalau tak faham juga boleh PM saya personally dan saya explain lah balik. So harap soalan lebih kurang macam tu je. Tak ada banyak sangat beza dengan yang lepas-lepas. So kalau faham dia punya konsep flywheel, then should be no problem lah. So we've done with our first part of our course, which is machine. Alright, which is machine, and then for next week we are going to continue with the second part of our course, which is vibration, right? Which is, I think, a very interesting topic for vibration. Okay, so we are divided into 5 parts of vibration. First one is we are going to discuss about interaction first. Of course, interaction of vibration first. And then we have free undampened of first degree of freedom. We also have free dampened of 1 degree of freedom. And we also discuss with about force dampened 1 degree of freedom, and then we continue with 2 degree of freedom with free undampened and force undampened for 2 degree of freedom. So just bear in mind is your final exam, all right, we have 3 equations comes from vibration. 3 equation out of 6, all right, 3 equation comes from vibration. Another 3 equation comes from machine topic, all right, but you need to choose only 5 instead of 6 questions, all right, because question number 1 and 2 is optional. You just only choose either question 1 or 2, all right, so you need to answer all 5 questions for final exam. For tests, again we have same as what we did on test 1, 3 question. Question number 1 is about, if I'm not mistaken, is about balancing. Question number 2 is also balancing, reciprocating. Question number 1 is about radial. Sorry, not radial. Apa? Yang first tu, yang inline inline macam tu lah. Inline, and then number 2 adalah reciprocating, and then question number 3 is about flywheel. Tu je. Alright. About your project, saya tengah siapkan soalan. So bila dah siap nanti, mungkin by dalam seminggu 2 lagi siap insyaAllah lah. Dah siap nanti saya akan buat undian lah, which question yang setiap group akan dapat. Alright. Susah ke projek tu? Nak cakap susah tak susah, ya, mungkin susah dalam segi part of macam mana you nak write ataupun nak writing your script dalam MATLAB program lah, dalam coding. Alright, yang tu kena faham lah, kena belajar lah, because there is one of the criteria, one of the apa kita panggil PLOs, because this project comes from your PLO number 3, which is requires you to apa, untuk boleh handle the project given. Alright, so tak apa, so kalau tak faham banyak benda, banyak source ni you boleh belajar. Dan yang paling penting at the end of the project you boleh tahu macam mana you nak handle the problem given, right? Because that's why this is a group project, so just discuss among of you macam mana nak bagi tugas setiap part yang ada lah. Alright. Soalan berkaitan dengan gyroskop, ada juga part yang memerlukan manual calculation, and the main part is about writing your MATLAB script coding lah, yang tu paling penting. And then ada graph yang kena buat using MATLAB. That's it. Okay, so any other question ada? So kalau tak ada soalan, then don't forget we have attendance. Kan saya dah bagi attendance. Tak scan lagi. Kejap. So kalau scan. Kalau tak ada soalan, dan jumpa next week lah, hari Rabu, dan kita akan masuk new topic, which is vibration. So thank you very much for your cooperation today. So you can leave now. Alright, so thank you very much. Siapa yang tak scan boleh scan lagi, dan you can leave, you can dismiss. Assalamualaikum.